Imagine the beginning of time. Billions of years ago. There was almost nothing but water. Over time, the world changed. Except the water, which was still there. Throughout history, the same water. Well, almost the same. 4-billion-year-old water. Water moves in a circular pattern, from the Earth's surface to the air and clouds, and then, as rain or snow, back to Earth again. The water cycle is nature's boomerang. What drives this water cycle is the sun, as it causes water on the surface of a lake or a pond to evaporate into water vapor. This rising water vapor is held in the atmosphere until it cools down and joins other moisture to form clouds in a process called condensation. And when the moisture becomes heavy enough, it falls back to Earth as precipitation, seeping into the cracks of the Earth, soaking underneath the ground, forming groundwater. Some, returning to the surface water, begins the process all over again. This cycle began billions of years ago, and it's never stopped. It's the same water moving in a circular motion, always returning to Earth. So you can see that the water we have now is all we've ever had, and all we'll ever have. Let's look for a minute at the connections of our water. We saw how rain returns to form surface water, our lakes, streams, and oceans, and to form groundwater, as wells and springs. These are the sources that supply us with our drinking water. And once we've used water for washing, farming, recreation, it then becomes wastewater. So they're all linked to each other, really, in a kind of interrelated system. What affects one can affect all, and us. You can see this with the spread of pollution. Some people think that if they dump waste into rivers, that it just goes away, but it doesn't. It all comes back eventually. That's what that old saying means: we all live downstream. Our lakes, rivers, and streams do clean themselves, but it takes time. And with so many more people in an increasingly complex world, water's natural ability to clean itself can be overwhelmed, and the balance between people and nature becomes threatened. Our response to these dangers is to devise the best method yet known to clean our water efficiently: the wastewater treatment process. We begin by collecting the used water as wastewater travels down drains in homes, schools, industries, and the streets, entering a massive network of pipes, itself an incredible engineering accomplishment, our sewer system. In most areas, millions of gallons of wastewater enter the sewers each day. Once in the system, the used water begins a journey that will bring it back to nature. But first, it takes a major and essential detour to the wastewater treatment plant to be cleaned. This is our last defense against water pollution. A wastewater treatment plant is modeled precisely after nature. But what nature does so simply has taken everything we know about chemistry, biology, hygiene, engineering, hydraulics, and electronics. This vast complex of technology requires the expertise of thousands of professionals: chemists, engineers, lab technicians, wastewater operators, and supervisors. The people who make this minor miracle work. Once in the plant, wastewater travels through various stages of purification: primary treatment, secondary treatment, and often even advanced treatment. Using the same basic physical, biological, and chemical processes as in a lake or stream. But let's look a little closer. In the first line of defense, primary treatment, the larger solid materials are removed by several physical or mechanical methods, such as screens and filters. As water is pumped through the system into skimming devices, they catch and remove particles after they settle to the bottom or float to the top. This same settling and floating action occurs naturally when a river or lake cleans itself. After primary treatment with its mechanical devices, secondary treatment begins, using biological methods, again learned from nature. You've seen how water in a river or stream flows over rocks or swirls around itself, creating foam. This is natural aeration. The water is mixing with air, and the air's oxygen feeds certain bacteria in the water, which help to remove pollutants. These aeration basins in secondary treatment simulate this very same process. In another secondary treatment method, we spray wastewater over a rock-like bed covered with a layer of biological slime, bacteria and fungi, which help to eat pollutants. Once again, we've taken our cue directly from nature. Of course, all during these treatment stages, the wastewater is constantly tested to make sure it's being cleaned properly. Once both primary and secondary treatment are completed, the water is ready to return to the rivers and lakes in many areas. But not all areas. Some local waters are more sensitive or have different chemical balances, so even more treatment is needed to remove pollutants. This is where advanced treatment comes in, using a combination of chemical, biological, and mechanical methods. Here, wastewater passes through more filters, granular materials like fine sand, coal, or gravel, nature's filters, sifting out particles that the primary and secondary treatments missed. Special chemicals may also be added to remove nutrients which may be harmful to fish and to the rivers and streams. And so, all the stages are now complete. What once entered the plant as polluted water is now in two separate forms: the cleaned wastewater, called effluent, and those solid and semi-solid substances we removed from the wastewater in primary, secondary, and advanced treatment. This heavy material gets its own treatment before it's released and reused. Special processes convert it into drier, mud-like material, so it can be incinerated, put into landfills, used as fertilizers, or even as fuel. The cleaned wastewater, the effluent, is finally safe to be returned to the environment, to be discharged into local surface waters. Effluent can also be used for land irrigation and occasionally to replenish groundwater supplies. Remember those important links between surface water, groundwater, drinking water, and wastewater? Wastewater treatment is only one part of the overall water picture, but it's a vital part. Without treatment, allowing wastewater to build up and contaminate our lakes, rivers, streams, and groundwater, our taps would run dry, our lifestyles would collapse, our health would be at risk, factories would grind to a halt, and much of our food would disappear. Our entire society would begin to unravel. Water is not just a matter of convenience or even of beauty. It's a matter of survival. More than ever before, we can protect our water, as we protect our air, as we protect our wildlife. Clean, healthy, beautiful water, now and for our future. Water, all we've ever had, all we'll ever have.